There are two ways to get your head around the exact values. One of them is to learn the hand trick, and one of them is to memorise the table. They're the two ways of doing it, basically. So you've got these values, you need to drag and drop them into the table. The one thing I will say is that the value, the value 1 is tan 45, okay. The value 1 over root 3 is tan 30. More often that is written as root 3 over 3, just to let you know, okay. And the final one, root 3, is, I wrote those completely in the wrong order. Never mind, I'm not printing it out again. We've then got a half. Now a half is in two different places. It is one angle for sine and one angle for cos. That's 30 and 60. You've just got to remember which way round they go. Sine starts off small, so sine is a half. Cos finishes up small, so cos 60 and a half. The opposite sides. Equally, root 3 over 2 is both of those, but the opposite way around. This is root 3 over 2, and this is root 3 over 2. And the one that's left, 1 over root 2, is both of them from 45 degrees. More commonly, that is written as root 2 over 2. Learn your table or learn the hand trick. The hand trick is sine equals the square root of the bottom fingers over 2. Cos equals the square root of the top fingers over 2. And tan equals the square root of the bottom fingers over the square root of top fingers. And that is where, when you look at your hand, this is 0, your pinky is 0, your ring finger is 30, 45, 60, and thumb is 90. So for example, for cos 60, 0, 30, 45, 60, this one here. Cos is the square root of your top fingers over 2. There's only one finger on the top, so it's the square root of 1 over 2, which is 1/2. Third question, double bits. First time we're actually using Pythagoras in this homework so far, which is in the bottom triangle of question 1. We cannot find x because we need two pieces of information to find out the third. We only have one piece of information for the top triangle. I know that the whole thing's a triangle, but it's not a right angle triangle, so that may as well be a chocolate teapot. So what we need to do first is we need to find the side they've got in common, which is this side here. And to do that, we're going to use Pythagoras. We're going to do 9.2 squared. We're going to do 7.9 squared. We're going to take them away from each other, and we're going to square root the answer. I've done that all in one step because I don't have a calculator. I did these on my phone earlier, and now I can't remember what my working looked like. So we do that, and that gives us 4.71. So I can then label this side here as 4.71. You'll notice I've used two decimal places. It says one decimal place here. So what I do is I make sure my workings are more accurate, and then I finish it off by rounding to one decimal place. Now this has an angle in it, but we need to find the angle, so we're going to use trigonometry. Opposite, nothing on there. Adjacent, that's 4.71, and 5.5 is the hypotenuse. So what would we use? We'd use cos. So cos for angle x equals 4.71 over 5.5. We need to do cos inverse on our calculator, shift cos. That's going to give us 31.1 degrees. This one here, we use trigonometry both times because it gives us the angle both times. Again, we're going to find the side that they've got in common, which is again the horizontal side. So using trigonometry, this is our opposite, this is our hypotenuse. So we're going to be using sine. It's sine for a 32-degree triangle. The opposite is our number here, which I'm going to call x, over 9.7. So I'm going to do 9.7 times sine 33, which gives me 5.28. So this is 5.28 centimetres. Finally, we look at the top triangle, new angle, so a new label. That's why I didn't write the labels on a minute ago. If you've got a question like this in an exam, my suggestion would be to draw out the bottom triangle on its own first and label that diagram, and then again draw the top triangle out on its own and label that diagram. That will stop you from having too many labels. So here's my angle. Y is my opposite. 5.28 is my adjacent, so I'm using tan. Tan of the angle 5.1, now think about it, 5.1 degrees is really, really small. So we're going to expect a really small answer. And in fact, when we do 5.28 times by tan 5.1, it gives us the answer 0.5. Really is a very small answer. But does that make sense? Well, yes, it does, because think about it, that's a tiny angle. Remember, they're not drawn to scale. So the slope's going to be tiny. Not going to go up very far at all. Final question, I'm going to zoom through this one a bit faster. We've got the bottom triangle. Again, we need to find the side in common. Trigonometry, adjacent, hypotenuse. Find so that's going to be cos 53 equals 4.1 over, let's call it x because x is the mathematician's go-to number. The unknown is on the denominator of the fraction, so we're going to divide. We would do 4.1 divided by cos 53, which gives me 6.81. So this side here is 6.81. Think about it, does that make sense? Yes, it's the hypotenuse, it should be the longest side. And then finally for this triangle here, I again use trigonometry. Opposite and adjacent, I'm using tan. Tan 41 equals opposite 6.81 over adjacent, which is z. Again, the unknown is on the denominator of the fraction, which means I'm going to divide 6.81 divided by tan 41, giving us 7.8 centimetres. Excellent. Now, this question, or whatever version of this question appears in an exam, often foxes people, because they're like, hang on, this is bearings. Bearings are just angles. The important things to remember are never each shredded wheat goes clockwise. I still use that myself. Incidentally, I quite like shredded wheat. Only the small ones, though, not the big ones. That's neither here nor there. Anyway, first of all, we have a triangle here. So let's make our triangle by drawing the line AC. And we want to find the distance from A to C. That's a right angle triangle. We don't have any angles at the moment, so we're going to use Pythagoras Theorem. We're going to say that we've got 100, and we're squaring it. We've got 75, and we're squaring it. And we're trying to find the hypotenuse. Now, because the hypotenuse is the longest side, we're going to add our answers there, and we are going to square root what we end up with. That gives me 125. Again, that's one I calculated earlier. Calculate the bearing of A from C. Give your answer to the nearest degree. It's important that we remember about bearings 3 things. Number 1, they have 3 digits. They're called 3-figure bearings. So, number 2, we always start from north because north is 0. And number 3, we always go clockwise because clockwise. So, we are going to A from C. So C is where we're going to start. Remember, this is our north. And we are going to go clockwise, that's this way, round until we hit that line going back. We want that angle there. Okay, so can we work out any of that using trigonometry? Yes, we can. We can work out this angle here, my green angle. I'm going to return to pen because I haven't got much writing room, and it takes a lot of space. So, let's label my triangle. This is my angle, this is my opposite, and this is my adjacent. So I'm going to use tan. Tan equals opposite over adjacent. I'm not going to write that one out because we've written it out so many times today. X equals opposite 100 over 75. Make sure they're the right way around. It's so tempting to always make sure your fraction is not top heavy, but some fractions are top heavy. That's just part of life, okay? So we can find that angle by doing tan inverse. Remember, you can do this as a fraction or as a division, depending on your preference. Just make sure that bracket goes there in your calculator, and that gives us the angle 53.1. Well, you might say, fair enough, but we don't want to know that. We want to know all of this. But if we take the green angle out of the equation, then we've got the blue angle left. And this is where the knowledge of never each threaded week comes in. This is north. This is east. This is south. And this is west. Which means that this line here must be southwest. How is that useful? Well, we know that that's 0. That's 180, so that must be 90. That must be 270. So halfway in between 180 and 270 is 225. So southwest is 225 degrees. So what we want is the blue bit, which is southwest, 225, and the green bit, which we've just worked out, is 53.1. So when we add those two together, I'm not going to bother about the 0.1 because it was read that it says nearest degree. 872, bearing would be 270.